Welcome to day 44 of the school year. Let's get down our beginning fraction. A total of 180 days. We are on day 44. Now we want to think, is 44 prime or composite? Well, it's an even number, so that means it is composite, because the only even number that's prime is the number 2. So it's composite, and that means we need to do our prime factorization for both the denominator and the numerator. All right, let's see. 1 plus 8 is 9, plus 0 is 9. 9 is a multiple of 3, so 3 is a factor. I can get 6 groups of 3 out of 18, and then I have 0 because of the placeholder. It's even, so I can divide by 2. Half of 60 is 30. I can divide by 3. I get 10. Half of 10 is 5. 44 is even, so I can divide by 2. I get 22. Half of 22 is 2. I get 11. 11 is prime, so we're done. Remember, all the numbers on the outside here have to be prime numbers that we're dividing by. You can divide by other numbers, but we have to make sure that they're prime when we're doing prime factorization. Let's go ahead and get down our prime factors from least to greatest. 2 times 2 times 3 times 3. Oh, there's my other 3 times 5. 2 times 2 times 11. Well, I already see what I have in common. 2 times 2. That leaves 11 in the numerator. 3 times 3 is 9, times 5 is 45 in the denominator, 11 45ths. And 2 times 2 is 4. So our greatest common factor is 4. So let's go ahead and put everything into groups of 4. Remember, your groups do not have to look like mine. You just have to have 4 in each group. And make sure that we have our shaded separated from our unshaded. I like using perfect squares when I can. 4 is called a perfect square because you can make a perfect square. When you have the same factors, you could make it into a perfect square because it has the same length and width. All right, now let's count up our total amount of groups. Since each of my rows has groups of 5, I can count by 5. 5, 10, 15, 20, 25, 30, 35, 40, 45. And I have 5, 10, 11 shaded in. Now that we've done our division with our model, let's go ahead and do it with our algorithm. So we're dividing using our area model, groups of 4. 44. Let's see, 4 quarters is 100 cents. So 4 times 25 is 100. Number's the same, zeros a game, more on top, no need to stop. Bring that 80 up here, and then 20 times 4 is 80. Number's the same, zeros a game. 25 plus 20 is 45. Okay. Down here, 10 times 4 is 40. More on top, no need to stop. Numbers the same, zeros the game. Bring that 4 up. 1 times 4 is 4. Numbers the same, zeros the game. Add those partial quotients, I get 11. So now we want to check with our inverse operation. Divisor times quotient plus remainder. Divisor times quotient plus remainder. Since our remainder for both is 0, and the identity property of addition says when you add 0 it stays the same, we don't actually need to add the 0. 4 times 5 is 20. 4 times 4 tens is 16 tens, plus 2 more tens is 18 tens, or 180. 4 times 1 is 4, so 4 groups of 1. 4 groups of 10 is 40. 44, that matches our dividend. 180, that matches our dividend. Check. So our numerator is definitely 11, and our denominator is definitely 45. Alright, so now let's go ahead and fill in our data collection page. We are still in trimester 1, week 10. Today is 10/9/19. And our fraction for today is 11/45. Let's go ahead and get out our number line. We did groups of 4. Let's go ahead across. 9/45. Well, that's equivalent to 12/60, 18/90, 6/30, and our simplest form, or equivalent fraction in lowest terms, 1/5. 10/45 is equivalent to 2/9. And then today, 11/45. We do have an equivalent fraction in our 2's. 2 is a common factor. And then, of course, 44 180th. But this is our simplest form, our equivalent fraction in lowest terms. Go ahead and put your number line away, erase your worksheet, and thank you for joining me.